Thank you all for joining us today. I am Wendy Heinzelman. I'm the Dean of the Hajim School of Engineering and Applied Sciences, and it is my pleasure to welcome you all to this panel on harnessing the potential for big data in the 21st century. We have a wide range of registrants joining us for this session today, including students, prospective students, parents, and alumni, and I welcome you all to what I am sure will be a lively and engaging conversation about the future of data science. Data science focuses on the concepts, methods, and applications of extracting meaningful information from complex, detailed, and often uncertain and messy data. This requires a range of expertise, from AI and machine learning to statistical analysis techniques. But even more importantly, this requires domain expertise to understand the underlying models behind the data and draw inferences and conclusions from the analysis. Recognizing the need for interdisciplinary approaches to data science, at Rochester, we began developing data science expertise across the university over 10 years ago, and our focus in this area has continued to grow and encompasses almost every discipline at the university, from education to music to medicine to business, as you will hear today. And our work in data science includes not only the tools and techniques and applications, but also a look into the ethics and business practices necessary to effectively and ethically use big data moving forward. Before I introduce today's panelists to tell us more about data science at Rochester, I would like to offer my deep appreciation to University of Rochester alumnus Bob Huang, who had the foresight to make today's program possible. Bob made a significant investment in the University of Rochester in supporting programming and technology and innovation in the Bay Area, and today is our first virtual event for the Huang Speaker Series in Technology and Innovation. So a big thank you to you, Bob, for your generous support of the university. Now, I would like to briefly introduce our panelists. First, we have Mujdat Chetan, who is the Robin and Tim Wentworth Director of the Gergen Institute for Data Science, the Director of the New York State Center of Excellence in Data Science, as well as a prolific researcher and professor of electrical and computer engineering. Next, we have Shevin Yeltigan, who is our new Dean of the Simon Business School, an award-winning teacher and a highly respected macroeconomics scholar. And finally, we have Michael Hasselberg, who is the first Senior Director of Digital Health at UR Medicine, the Chief of Innovation and Technology in the Department of Psychiatry, and an accomplished Associate Professor of Psychiatry and Clinical Nursing. So thank you again all for joining us today. And now I will turn it over to Mujdat to kick us off.
Thanks, Wendy, and thanks everyone for joining us today. I'm the director of the Gergen Institute for Data Science at the University of Rochester, and also the director of the New York State Center of Excellence in Data Science. The Gergen Institute is an academic unit at the university with a campus-wide education and research mission in data science. The Center of Excellence supports industry-academia collaborations to create economic impact based on our data science research. As I'm the first panelist today, I'll provide a broad introduction to data science at the University of Rochester. Next slide, please. Let me start by talking about what data science is and what led to what some see as the data science revolution today, and what role academic institutions are playing and should play in this new domain. Data science is a burgeoning field that brings many opportunities and many challenges. As Wendy pointed out, it involves the concepts, methods, and applications of extracting meaningful information and insights from possibly large, yet complex and uncertain data. It has the potential to change almost all aspects of our lives. So current application domains, as shown in the slide, include a smart home environment, as shown in the bottom right, that, for example, recognizes your speech and acts upon it, but also learns your preferences over time and adapts to them. There has also been major recent progress on applications like autonomous systems, particularly autonomous cars, as shown in the middle of the slide, which can act upon complex multimodal data in real time to perform automatic navigation. While there have been successes in some domains, there is also potential in other areas. This includes addressing problems in environmental science, energy, sustainability by more effective use of data science. Social and political science is another domain that can potentially be changed in a major way by data science. One can even think of new, more effective modes of participation in a democratic system with quick access to people's opinions and on issues. So observing all of these existing and potential applications, one can ask, well, is this all new? The answer is yes and no. One can argue that data have always been the lifeblood of science. So why are we talking about a revolution and coining the term data science now? So the answer is we are witnessing an extremely accelerated progress in our capabilities to automatically extract information, in some cases in real time, from complex data. And this is changing the way we approach and solve problems. There are, I think, three main factors that led to the emergence of this new paradigm. First, of course, is the availability of large amounts of data. This is made possible by the internet, social media, smartphones, and also a variety of sensing technologies, which can be called Internet of Things when they are part of a network. So connectivity has enabled such data to be accessed remotely and also in real time. So the second important factor has been advances in computing power and storage. This includes things like GPUs, cloud computing capabilities, which made it possible to process large amounts of data to extract information from them. And the third factor that led to the data science revolution has been major breakthroughs in artificial intelligence and machine learning algorithms. These algorithms have led to amazing successes in areas like speech recognition, computer vision, game playing, etc. In addition, easy access to open source implementations of these algorithms and their ease of use enabled non-experts to take these tools and apply them on new problems, which greatly increased their impact. So all of this motivated new ways of interdisciplinary thinking on data-driven problem solving, leading to a new domain and essentially a new profession. This also posed questions to universities in defining the role they should play in this domain. This includes questions like, well, how to enable interdisciplinary research in this new area, how to define the emerging profession of data scientists and how to train data scientists, how to collaborate with industry in advancing the field, how to facilitate the use of data science to benefit the society. So I'll tell you just a bit about how the University of Rochester has been responding to these questions. Next slide, please. So let me first give you a timeline on data science at the University of Rochester. So the university was ahead of the curve in this space and acted early to become a leading institution in data science. Around 2005, the university realized the need to launch computational initiatives, and in particular, shared computing resources for data-intensive research. As a first outcome, such shared facilities were created in 2008, when the University of Rochester became one of the first academic institutions to own IBM's Blue Gene P supercomputer system. This infrastructure has been updated and expanded over years. In 2013, the university named data science as top priority in its strategic plan. In 2015, the Gergen Institute for Data Science was established. The Gergen Institute was one of the first data science institutes globally, and it was also one of the first to offer an undergraduate degree in data science. Finally, over the last few years, we have been strategically expanding our programs and efforts in data science and increasing their impact. Next slide, please. Next slide, please. So today, data science continues to be a top priority for the University of Rochester. The Gergen Institute has become one of the leading data science institutes nationally and globally. Our dimensions of activity in data science include research, where we build on the university's areas of academic strength to solve problems, foundational problems, and applied problems in data science. We offer successful educational programs in data science that attract increasing number of candidates. To our students, we offer a distinctive education within a diverse, inclusive, and supportive environment to enable them to pursue careers in data science. We support industry-academia partnerships through our Center of Excellence to contribute to the regional and state economy. Finally, we work with various stakeholders in the community to facilitate the use of data science to benefit them. Next slide, please. To be able to do all of this, our most important asset is our faculty. 75 faculty members from 6 schools and 30 departments across the campus are affiliated with our Data Science Institute. This includes faculty from the School of Arts and Sciences, Hajem School of Engineering, School of Medicine and Dentistry, Simon School of Business, Eastman School of Music, and Warner School of Education. This extremely interdisciplinary environment enables us to work on a variety of data science problems by bringing together domain expertise and methodological expertise. Next slide, please. Specifically today, our Data Science Institute is focused on 7 strategic areas in data science. My fellow panelists are experts on 2 of these areas. You'll hear from Shevin on economics and business data analytics, and from Michael on health analytics and digital health. Our areas of focus include foundations of machine learning and artificial intelligence, which you see on the top left, where we not only develop new methods, but also aim to obtain a fundamental understanding of when and how well we should expect these methods to work, as well as how we can build in fairness, privacy, security into these new methods. Given our strong medical center, health analytics and digital health, as shown in the top right, is naturally an area of focus for us. We have significant activity also at the intersection of these 2 areas shown at the top. As an example of recent work at that intersection, when the pandemic started in March 2020 here, our faculty in these 2 focus areas got together and published one of the first articles analyzing the impact of social distancing measures on the spread of COVID-19. In the second row, you see 2 focus areas that are again built upon the university's strengths. In the interest of time, let me just mention one recent effort that's at the intersection of these 2 areas. We have recently received a grant from the Beckman Foundation to develop a new light sheet microscope and associated data science methods to help solve several important problems in biology. This is very interesting as a collaboration effort. It involves multiple departments, including biology, optics, biomedical engineering, as well as data science. As shown in the bottom left, human data system interfaces is another area of focus for us. Here, we develop data science methods for applications like augmented and virtual reality, human-robot interaction, as well as brain-computer interfacing. We currently have a PhD training program focused on augmented and virtual reality. Researchers from various departments at the university work on network data science problems with various applications, including all the way from neuroscience and smart cities to analyzing pandemics and astrobiology. Finally, economics and business data analytics is another area of interest, but I'll let Shevin talk about that. Next slide, please. So the other major asset we have, of course, is our amazing students with diverse backgrounds from all around the US and the world. So let me talk just a bit about our educational programs. Next slide, please. We offer educational programs in data science to learners all the way from high school level to graduate students and professionals. All these programs are structured to provide the 3 technical, a variety of technical and non-technical skills that a data scientist needs. In particular, our programs aim to equip the students with what we see as the 3 main pillars of data science, as shown on the top right here. This includes strong mathematics and statistics background. It also includes computer science skills, particularly algorithmic thinking and machine learning. And thirdly, this includes exposure to a domain of the student's choice, ranging from biology and physics to environmental science, business, and political science. In parallel with all of that, we also educate our students on ethics and expose them to team science and real-world project experience. Next, please. One of the ways in which we provide that real-time problem-solving experience is through our capstone and practicum projects, where groups of our students work with a customer to solve a real-life data science problem. The customer here can be a company, can be a nonprofit organization, or a government entity. Here on the right, I'm highlighting one project from fall 2020, in which our students worked with United Way and the Rochester Anti-Poverty Initiative on a project to determine the major needs and concerns of the community during the COVID-19 pandemic. Our students developed natural language processing methods to analyze open-ended survey data to extract insights about the community's needs and concerns. Next slide, please. In addition to our research and education efforts, we also organize many activities open to the public, This includes seminars by experts in a variety of fields related to data science, as well as focused events like the recent workshop we organized with the Department of Philosophy on algorithmic ethics. We would greatly welcome your participation in our future events. Next slide, please. So let me close by saying a few words on what I think the future holds for data science. Availability of massive data and the capability to extract information from such data provides enormous opportunities for improving human life, advancing science, and benefiting society broadly. In fact, focusing on this notion of data for good, data science may help solve some of the greatest challenges facing the world today. This includes sustainability, hunger, and the spread of disease. While there are a lot of opportunities, there are also lots of challenges as well. Some of these are technical challenges, but the non-technical ones are also as important. These include ethics, equity, privacy in accessing and using the data. However, perhaps more importantly and more interestingly, there's the challenge of building ethics, equity, and privacy into algorithm design. Ethics has always been on the agenda of scientists and engineers, but I would argue that data science and AI make it a required integral part of technical work, as this is not just about how a user or the society consumes a product, but whether the product itself behaves ethically and with fairness. In the future, I expect a lot of work on guidelines, standards, legal regulations, both on the use of data as well as on data science algorithms and the products that use such algorithms. So let me conclude by saying that the data science revolution is about taking a fundamentally new and hopefully better approach to understanding ourselves, our communities, and the world. This can potentially generate a profound positive transformation in our society if we address the associated challenges well. Next slide, please. So to finish, please let me just point you to our website. Please see the website of the Gergen Institute for more information about our work and our programs. And next slide, please. And also please follow us on social media. And that concludes my talk. Next will be Şevin Yeltekin, Dean of the Simon School of Business.
Thank you very much, Müjdat, for that very nice and broad introduction. Hi, I'm Şevin Yeltekin. I am the Dean of the Simon Business School. So I'm going to talk a little bit about from sort of a business economics and policy or social science, generally speaking, perspective. And the big data revolution has definitely had a very prominent impact on social sciences, on both the sort of the models and theoretical underpinnings of some of the work we do. We've always worked with data, but the availability and ubiquity of data has become a very important area that we have focused on in social sciences and have developed various additional techniques and tools to be able to address some of the business, policy, and economics problems, both of this century and sort of forecasting for the future. I want to give you a little bit of sort of understanding of how we in both the business, economics, and policy areas kind of approach data. And there's the sort of the data extraction and analysis, right? So this is just managing databases. And this has been revolutionized as well. We've gone from sort of having to have, put a lot of money and resources into having fixed sort of databases that we have to house to variable cost, as we say in economics and finance, that in the sense that now we can use a lot of cloud computing. So we want to have data, we want to have the tools, we want to have the techniques, and we want to have the expertise. To be able to make significant impact, we need to have all of those in one place. And we also need to understand the limitation of our analysis and techniques. In a lot of times, what we hear sort of outside of academia or in certain sort of places is lots of talks about the tools themselves or the techniques themselves, but a very good sort of foundational underpinning is extremely important because we want to understand how to exactly use that analysis and know its limitations. Just to give you some examples, for example, personalization and customization. Not only it's important for a consumer because we receive personalized and customized products, ads, information. At the same time, this has helped, for example, businesses save a lot of costs. What's the point of advertising to somebody new cars, somebody who's just bought a car, right? So you want to make sure that if you have data on folks who are looking for cars, as opposed to people who've just purchased cars, you can now sort of tailor your advertising to that, and that can save you a lot of resources. And this gives us sort of overall efficiency increases. Now, one of the other things that happens with data is that a lot of times when we're looking at sort of vast amounts of data, or even small data, as I call big data versus small data, a lot of the conversation revolves around correlation. And here's an example about correlation. Demand and prices, right? It's sort of the bread and butter of economics and business. And market forces. If you were to look at, say, in the Rochester area, what happens to the prices of hotel rooms during graduation, when we can have in-person graduation, you're going to see that the prices are going to go up. Imagine training an algorithm on that. What is the algorithm going to see? It's going to see that prices go up when demand is high. And it's going to give a positive correlation between demand and price. Well, demand and price in economics and sort of fundamental economic thinking is actually a downward sloping curve, not an upward sloping curve. So we need to understand not just correlation, but causality. So a lot of the social sciences, what we have been concentrating on as this data revolution is taking place is to how to harness all of that power of the new data, the size of the data that we can see, but at the same time be able to make what we call causal inference. Econometrics is a field that combines kind of statistical theory as well as data science, along with sort of applications to economic phenomenon. And there we use field and natural experiments to determine causality. Correlation and causality are two different things. And I'm going to give you another example of why that's really important. The other thing that the data revolution has done for us is the monitoring and contracts. Everything has become computer-mediated transactions, almost everything. That means that things that were unobservable, Slack rooms in people's houses, right, which has been the sort of the bread and butter of Airbnb, has become observable and hence contractable. We have fields in economics called market design. That's what Uber and Airbnb uses, actually, sort of the theoretical foundations from market design, and mechanism design. This is auctions all the way from sort of electricity licensing to eBay, where you want to sell maybe your grandfather's clock, right? And these fields have sort of put together the basic framework and how auctions work and how we can actually extract both efficiency and surplus from these. So there's a combination here of data tools, as well as understanding the sort of the statistical inferencing, but also combining it with exactly the sort of the domain expertise that Müjdat also alluded to be able to make impact, and to be able to understand really where the value of data can take us. So, you know, data visualization is great, being able to get correlations is great, but you do need that domain expertise to know how to extract that inference and be able to use it very effectively. Next slide, please. So let's talk about one particular type of sort of, big data analysis tool that when we talk about business economics and policy that we use very heavily these days. And, artificial intelligence takes many forms and shapes and flavors, and so does machine learning, a part of artificial intelligence. So I'm going to use a very specific definition of machine learning here, which is just algorithms designed to be applied to data sets, with the main area of focus being prediction. Usually that's what we see, which, in statistical analysis, we would call regression, classification, and clustering of grouping of tasks. So tasks can be divided into two branches. You can think of it as unsupervised, just throw a bunch of sort of, not labeled data at it, and the inputs are not labeled, and find, things like find similar videos to the ones that I have just watched, right? If you're on Netflix, on Amazon Prime, you'll see that after you watch something, there's going to be a recommender system operating underneath it, telling you what else to watch, or people who watch things that you have watched have also watched, right? And then there is sort of the supervised, which is the prediction part, right? Inputs are labeled. We want to look at somebody's income, somebody's past behavior to be able to tell whether or not they're going to be able to repay the loan that we're about to give them. This is going to predict output using training on existing data. This is the one that we hear about a lot as well. So how do we use them in sort of, policy and business decisions and economic decisions? Sometimes the decisions we make in business, economics, and policy rely on prediction. How likely is person X to repay a loan? So that when we're trying to make that decision about, what is the interest rate to charge and whether or not to give them that loan to begin with. Things like effect of neighborhood revitalization on property prices, right? And we can use prediction techniques that actually employ machine learning to be able to answer those questions. Some other questions really need causal understanding, and we really need to pin down causal effects. For example, if we change the price, what will happen to demand? If we raise the minimum wage, a big debate these days, what will happen to unemployment? Experimentation is not always possible. We don't get to move the minimum wage every other day to see what happens, right? We don't play around with tax rates to see how people respond and how businesses and households respond. So experimentation sometimes is not possible and sometimes certainly not advisable. In that case, what we need to understand, this is where models and frameworks and theoretical foundations come in really importantly, is that we have to understand kind of the behaviors that generate that responses. And we build models on that, and we use those models to be able to make inferences. We have, of course, stability, robustness, and fairness criteria. And this is not something new. So just sort of generally speaking, in a lot of the social sciences, every time we write down a policy problem we want to solve, if we raise the minimum wage, what happens? We need to have a criteria. There's lots of social criteria that we use when we do policy analysis. And to a large extent, these are criteria that we choose. So the idea that there's only one criteria out there and that's some sort of optimal criteria is certainly not true. And statistical fairness is different from social fairness. And we can talk about that in the Q&A a little bit more as well. So there are some choices out there. And there are certainly some trade-offs out there. And as an economist, trade-offs are my sort of bread and butter. And we need to think very seriously about sort of, where does the fairness criteria end of one type and where does sort of efficiency begins. And we need to be able to quantify those so that we can make informed decisions. So power of models, power of social sciences and behavioral sciences is that we need to understand the behavior that generates the data. Because something like machine learning prediction power really relies on stability of the environment. Financial markets get hit by crises. They're not that stable. Neither are pandemics. So we can't rely on stability. When we don't have stability, we need to understand the incentives and the behaviors and the models and the theory behind it. And this is why having some education that's beyond the tools and techniques in a place like University of Rochester, at all of these different schools that we have here that provide that training is extremely important. Next slide, please. Just to give you an idea, Müjdat showed you some of the educational programs that are at UR. We have at the Simon School a variety of analytics programs at the master's analytics programs in accounting, finance, marketing analytics, and business analytics, generally speaking, where we do actually, utilize these tools, techniques, but at the same time, we also show the students what are their limitations, how does causality differ from correlation, how can you make inferences, and how can you add value to the organizations that you're going to be a part of. So there are lots of activities going on, research, a tremendous amount of research. Our faculty at the Simon School are doing everything from sort of impact of ML to set, machine learning, text analysis, to be able to forecast financial returns. At the same time, they're looking at congestion in ICUs, predicting healthcare costs. So there's a tremendous amount of research going on at this university, at all of the schools that utilize and also push the envelope on data analysis. So follow us as well, and you'll learn more about a variety of our programs. So next, I would like to introduce Michael, and he'll take it away, please.
Thank you, Seven, and thank you all for having me today. Michael Hasselberg. I am the Senior Director for Digital Health at the Medical Center. I'm also a faculty member in the School of Medicine and Dentistry. As you've heard from my previous colleagues who have spoken, big data has transformed the world we live in. We live in a world where the largest automobile company doesn't own a single car, but offers on-demand transportation, including transporting patients to over 100 hospital systems across the country, and delivers prescription medications to the doorsteps of patients in 37 states. We live in a world where the largest hotel chain, Airbnb, doesn't own a single hotel, but can match a rental property based on one's own preferences. This is a company that was nimble enough during the pandemic to house over 100,000 healthcare providers free of charge. We live in a world where the largest retailer, Amazon, provides personalized and easy shopping experience where you can purchase just about anything with the click of a button. Even in their few brick and mortar stores, you can walk in, grab what you want, and just go. No lines, no checkouts, no registers. Through Amazon Care, Amazon has now set out to make healthcare easy. The company uses big data to provide virtual primary and urgent care to their employees, their families, and now other US-based employers. As a consumer of Uber, Airbnb, and Amazon, I love the convenience, transparency, and personalized experience these companies provide. I now expect the same great experience in all aspects of my life, including healthcare. I see a future world in which the leading health systems will own very few hospitals, but instead will leverage patients' own devices to not only monitor and deliver care, but also predict and prevent illness from even occurring. However, big data in healthcare is hard. A great example of this is a company founded in our backyard, founded in Binghamton, New York, a company known as IBM. In 2011, IBM wowed the world when its artificial intelligence computer system, Watson, defeated 2 human champions in the game show Jeopardy! Building off of that success, the company launched Watson Health in 2015 with the goal to transform medicine using AI. They spent over $4 billion acquiring healthcare data, but to date, they've not been able to turn a profit. And just last month, the company announced its intentions to sell off Watson Health. See, what IBM didn't account for was the reality that healthcare data is messy and in many cases inaccessible. Let's take a look at my own healthcare data. And let's start with my medical record. In the medical record, it's structured data. For example, it has the dates and times of my appointments over the years. It has my allergies, my past blood work, my current medications. It has vital signs and other biometric data that has been collected on me over the years. It has a list of my medical conditions. It even has an old chest x-ray when I had pneumonia as a child. But this data is not up to date. There are several medical conditions in my chart that I no longer suffer from. There are several medications that I no longer take. This data in my chart is not collected in real time and only gives a picture of my health at the time in which that data was collected. The biggest problem with my medical record is about 80% of that data is unstructured, and it's found in free text of thousands of clinical notes from different providers that I've seen over the course of my lifetime. What is not found in my clinical record is my personal experience and satisfaction with care. That I'm a person that would prefer a telemedicine visit for its convenience versus seeing a doctor in person. My medical record doesn't describe how I grew up in a small rural town where the majority of my community, and this is the town I still live in today, is below the poverty line. and is located 40 minutes outside of the city of Rochester. It doesn't include the claims data that my health insurance company has in terms of what my health insurance company will or will not pay for. Nor does my medical record include the transparent cost of what an appointment, a procedure, or a hospital stay might set me back. And unlike Amazon's trusted 5-star rating system, where one knows the quality of a product before they purchase it, the quality outcomes of my healthcare providers, they're not in my record. Data on staffing and wait times, data on available supplies, equipment, medications, vaccine availability, or what's in stock and what's not in stock. That's not in my record. My medical record doesn't tell me or my provider that the pharmacy in the town next to mine has an in-store discount program that could save me money on the prescriptions that I take. It doesn't include data telling me that health systems from New York City, Pennsylvania, Ohio are now offering virtual care in the greater Rochester market. When all of these data sources are looked at in silos and analytic models are applied to them, they produce results that are inaccurate. They only provide a sliver of what my overall health picture looks like. At the University of Rochester, under the leadership of Dean Taubman and Dr. Mike Rotundo, we are invested at the Medical Center of becoming a leading data-driven health system of the future. Driven by our enterprise data warehouse strategy, where we are aiming to combine all of these data silos into one warehouse where the data is structured so we can look at one's overall health. This is combined with our new 5-year digital first strategy, where we are aiming over the next 5 years to become a smart health system, a system where in the future, a patient's own data drives their experience within the system, helps stratify them to the right level of care at the right time and with the right provider. So how are we going to do this? The first part of our strategy is access. We want patients to be able to use their own devices, these smartphones, these powerful computing tools, to not only schedule their appointments with these tools, to receive healthcare through these tools via telemedicine and mobile apps. We want to keep our patients engaged through this technology. We want to be able to give our patients easier access to fill in those gaps in our current data that we're missing. Real-time data around how they're feeling, real-time data around their vital signs and their metrics using remote patient monitoring. And I'm not even talking about fancy peripherals. I'm talking about that Apple Watch, that Fitbit, and even again, the sensors within this own device. And then using this data, we can then apply it for good, and apply it for improving the quality of care that we have within our system at a lower cost and make sure it's personalized. So here's how the University of Rochester Medical Center is different from most academic medical centers across the country. And a lot of folks don't know this. We are only a handful of academic medical centers left in the country that roll up to a single university budget. Most academic medical centers have broken away from their parent universities. We have not elected to do that. And I say that's our differentiator. That's going to allow us to becoming a leading smart health system faster than the other academic medical centers that broke away from their parent university, and faster than those big tech companies like Amazon, which are really not connected to a health system. We at the University of Rochester have the opportunity to pair those brilliant data scientists, those brilliant computer engineers and computer scientists, those brilliant business scientists over on the River campus, partner them with the content expertise and domain over at the medical center to build machine learning models, AI models that actually work, that IBM wasn't able to accomplish. We have the expertise here at the university to do that. So with that said, I'm going to stop my share, and I'm going to invite my panelists back for questions that folks may have.
Great. Well, thank you all so much. That was really inspiring. I mean, the vision of the future that you all painted is one that will be brighter, smarter, healthier for everyone. So I think that there's a lot of really exciting things to discuss here. I'm going to start with, there's been a number of questions that have come in around privacy and ethics, because there are a lot of issues that people are concerned with on these regards. So I'll start, Shevin, with you, I think, in terms of big data. One of the questions asked, big data is also big business. Where do you see a fair place to draw the line regarding privacy? And this really comes into, you know, how much should businesses be able to access of our data? Who should own the data? Should it be the businesses owning the data, or should it be us, ourselves, that we own our own data? And how do we think about that?
Yes, so I mean, this is, you know, do I have a very kind of simple rule of thumb? No, unfortunately, I don't. I probably could have made some money if I did, but I think it's really important. I mean, some of it has to do with sort of how do we, it's the transparency of it, right? Whether we own data, I mean, I do believe that personally we should own our own data. But when we use certain types of, whether we go on the internet, where we use certain apps, whether we use certain platforms, you know, there is an understanding, and sometimes that understanding is not at all clear as to what we are consenting to. Right? Sometimes that's really explicit, and most of the time it isn't, right? How much of my data? Most people who are not very sort of technologically savvy, who do use the internet, and even those of us who are, don't realize that a lot of our information is being fed into the Facebooks and so on and so forth of this world, right? Whether we're, even when we're not on a Facebook page. So that sort of very kind of insidious way that the information moves around, I think, is the first place of tackling this, in the sense that there needs to be some guidelines about what exactly, every time we visit, whether we're set, you know, now we go and we have to set in the preference in every web browsers, we have to put some ad blocks, we have to read the fine print and so on. So there's no standard way of doing this, which makes it sort of both free for all and extremely costly on the part of the consumer to be able to tell exactly what did I just consent to, right? We don't see that with our financial data. We certainly don't see that with our health data. It's, you know, it's very structured. And the other thing I would say about this is that this is not just a conversation at, obviously not at UR or even just the United States. You know, Europe has been discussing this for a long time. The GDPR policy in Europe, we can, you know, we can talk a lot about how much of it we really want and not want and so on. But there is a collective sort of anxiety out there, rightfully so, about how we approach this problem. And at the same time, you know, where do we draw the line and what are some of the trade-offs? What I see a lot of times is sort of discussions at the two extremes without really a consistent sort of one, what are the standardizations of transparency that we want to provide? And what are the trade-offs? I mean, there's some really good public good here that also gets generated by data. And can we actually technologically put some limitations on what is publicly accessible versus what is private information as well? And I think we need to start the conversation somewhere, and we need to start it from those three elements.
Thank you. And Mujdat, a little bit along the same lines, but more on the ethical side, there's been some questions about facial recognition systems, for example, and I know you are an expert in these areas. Some AI systems have been criticized for being racially biased. Can these systems be fixed by simply retraining them with more diverse data sets, or is there more to that? Is it that the algorithms are biased? Is it we just need better data? How do you think about bias within data science algorithms, given that there is bias in our world?
Yeah, that's a great question. So indeed, there has been shown bias in a variety of algorithms, including face recognition as well as medical diagnosis in areas like dermatology. So data is one aspect, and it's one of the most important aspects. The data should be diverse and inclusive of the population. That's certainly a starting point, but it doesn't end there because there are other aspects of the process. One is Shevin talked about supervised learning. In supervised learning, we have labels. So, and then in many cases that those labels, in some cases they are physical ground truth, but oftentimes they are labels that are marked by experts. So there could be also bias in that process, intentional or unintentional. And then when it comes to the level of techniques and algorithms, there is room for bias in that process as well, all the way from how we process the data, how we extract features, and finally, how we perform inference on the data. So after all, these types of techniques now became so complicated that they are essentially nonlinear functions mapping from one space to the other, but it's very hard for a human to understand the nature of that nonlinear function. So going to the future, what I expect is that, so currently, when we test these machine learning data science algorithms to verify their performance, we do a lot of cross-validation tests, which verify performance on some held out data before they are used in practice. But we do this currently for performance. Going to the future, I think that will be done for things like fairness as well. So I think that in the future, just like, I mean, so in these domains, we don't have these formal trials and things like that, unlike a medical process or a drug, but I think those will appear. So we will have processes in which there will be a process for testing the fairness and ethics of an algorithm and a product that uses it before it's approved for public use. And that has to be a data-driven approach itself, because it's very difficult for a human to sit down and figure out if there's a major issue or not.
Yeah, great. And Michael, along the same lines, a question came in from the audience about, with respect to the advancements in technology and healthcare, what are the challenges that you see that exist in gaining the trust of the public to trust these technologies? So, you said you prefer, for example, a telehealth visit. Others may not. How do you get more people to trust the technologies that are going to be important in future healthcare systems?
Yeah, I think it gets back to Seven's point around transparency. I think in a lot of ways in healthcare, we have not been totally transparent with a lot of what we do. When I think about like the technologies that we use to provide these services, these are the same technologies that our patients, our consumers are already using for everything else. Everyone's using Zoom these days for their meetings or their kids going to school, and they trust the security around it for that. It's the same kind of technology that we're using in healthcare with safeguards. But what we have not done well is provide the data back to our patients. And so at the U of R, we've taken this initiative called Open Notes over the last year, where we are giving our patients full access to their medical record. And up to that point, it was jumping through hoops if you wanted to get access to your own health data. And I think that's a step in the right direction of building that trust and building that confidence that we can use those same technologies that we're using everywhere else in our lives for healthcare purposes.
Great. This question, I think, is for any of you. In any of your domains, are there any ongoing projects or ones that were completed related to COVID-19? How did data science help us, either at U of R or in the world writ large, to understand and to address the challenges created by the COVID-19 pandemic?
I have a great example from the medical center side. The first surge that we had in March, the biggest issue that we had was there was not enough PCR tests to go around to know, who may have been exposed, who's at risk for COVID. And so, it was really hard for us to allocate our resources and know where to focus in around social distancing or going back to work. And so, what we did is the U of R led an initiative called Rock COVID, where we partnered with all the community-based organizations. We partnered with the Data Science Institute. We partnered with Rochester Regional Health, the other health system in our area. And we offered a symptom tracker that folks could use every single day to say, are they having any symptoms related to COVID? Then on the back end of that symptom tracker, we were able to do geo mapping and hot spotting and kind of know and predict, hey, this zip code, there's something happening. We're seeing a spike in fevers. We should get what limited PCR tests we have out to that zip code and try to contain it. And so that was a prime example of in the world that I live in of how we used big data and data science to help with the COVID pandemic.
That's the personalization and customization piece I was talking about too, that in the sense that you could immediately customize, if you have a supply chain, we do this with flu vaccines too. Where is it moving? Almost like a storm or a tornado watch, you're sort of watching it spread across. And now you can deploy, where should we actually have these sort of supplies that are needed in these communities before it gets there. And it's very powerful. It's incredibly powerful and cuts across a lot of different sort of efficiencies and also, most importantly, in terms of delivering better outcomes for patients and for the community.
I can add just a few more. So in my presentation, I mentioned some of our student projects. One was this work that they did with United Way and Monroe Anti-Poverty Initiative on analyzing data from the community and trying to figure out what the needs of the community are in COVID-19. So we have these types of student projects. There is one this semester going on analyzing with the Rochester City on analyzing COVID-19 and crime. There's another one that we are involved with URMC in analyzing COVID-19 and vaccine sentiment. So these are student projects, but at a higher level, at the research level, one of the projects I also briefly mentioned was last year when the pandemic started, a group of faculty got together as an ad hoc working group to work on analyzing the effect of social distancing measures on the spread of COVID-19. And they did a state-by-state analysis in the US. They published this as a paper back in May 2020. Since then, there have been a variety of efforts, both in computer science and public health sciences. In public health sciences, Elaine Hill has been working on analyzing COVID-19 and pregnancy, looking at relationships there. There has been also work in computer science, analyzing things like social media data to analyze sentiments, again, around COVID-19. There has been work in biomedical engineering. Jim McGrath has been developing this fast test on basically COVID-19, fast test for COVID-19. And finally, there have also been a couple of projects on modeling the spread of the disease. And this is a collaboration between multiple departments at the university, including physics and engineering, which had looked at things like, well, how does the structure of a city and the social distancing measures in a certain type of city affect the progression of the disease, whether the city is a clustered or a distributed city. And in this context, what is important, just to support Shevin's point, it wasn't enough to just look at correlations. What we are interested in causal models, and also that requires developing models that you can then test and verify and do predictions on. So these are a few examples.
Great, thank you. And unfortunately, we're just about out of time, but I have one more question that I think is a really good one, since obviously there's a lot of opportunities in this area in the future. What do you propose, or what advice do you have to parents who are thinking about, how do I get my kids on a path so that they can pursue this type of field moving forward? What are your suggestions for sort of a career path, and thinking about students at even the K through 12 level up through undergrad? And even, I would say, Michael, in your case, I think there's opportunities for training of doctors and of people who are already working in the healthcare field. So your thoughts a little bit on that as a final question.
Yeah, as I kind of mentioned in my presentation, truly a differentiator for us as the medical center is we are truly one university. And with that, we can partner our medical students, our nursing students, our attending clinicians with the technology experts, Wendy, and in your school, with the business experts in Slevin's school, and then Mujat with the data scientists. And at the same time, I actually just had an engineering student join me in one of our ORs to take a look at the processes as we are trying to develop our virtual reality intervention to reduce pain and stress pre-surgery and sedation. So we give the opportunity for the technology folks to enter the health system and the health system folks to see, what types of technologies and data science, computing algorithms are available that could really improve healthcare. Yeah. That's unique to us. It truly is, and folks don't realize that is unique to the University of Rochester.
Yes, I think I would add to that. What's really, I think, important is that a lot of times, because of the name science, I'm talking more about sort of high school kind of aged prospective, maybe undergraduate students, is that they think, this is all about maybe kind of mathematics and applied to engineering and so on as well. What's really important here is that it's a precision of thinking. So if you are really comfortable with sort of both kind of mathematical precision thinking and get a little bit of training, a little bit of math, a little bit of coding, if you have access to statistics classes in your high school, the paths are enormous. I mean, you just saw a selection, everything from healthcare to political science to humanities, which we didn't have a chance to represent fully, but these skills have become fundamental skills, kind of like writing and speaking and so on and so forth. And you are not pigeonholing yourself in any type of field when you learn these fundamental skills. So come with an appetite, come with an interest, come with some comfort with math and statistics, and the world is your oyster, really.
That's all well said. So let me just add a few more words. So I think the key is exposure. So please expose your children to this area, and there are a variety of ways to do it. Some are much more involved, some are easier. We at the Gergen Institute provide these types of opportunities all the way from high school to undergraduates. These could be undergraduates in data science as well as undergraduates in other disciplines, to master's level education all the way through professional. So that exposure is very helpful. And I think that, different people can come with different backgrounds and interests, but I agree with Shevin. Statistics and probability, that's the way to understand data and make meaningful inferences. So that's one thing I would definitely recommend for high school students.
Great, thank you all. This has been a really inspirational panel. As I said in the beginning, I think the vision that you have painted of the future for how data science is going to be a part of pretty much everything we do is really compelling. I think there's a lot to be done. There's a lot of challenges. There's a lot of opportunities as well. And it's great to hear about all the work going on here at the University of Rochester. I know, unfortunately, we did not have time to get to all the questions in the Q&A, and there were some very specific ones. We'll try and follow up after this session. But I just want to take a second to thank all of you for joining us today. I hope you were as inspired as I was in what you heard. And we would love to hear your feedback on this webinar that we've held today. So if you wouldn't mind, please take a moment to share your thoughts on the session through a brief anonymous survey. A link is going to appear as soon as you log off. You click OK or continue, and it'll take you to a very brief survey. We'd love to get your feedback. But thank you, Michael and Shevin and Mujdat. Really appreciate your time and sharing your wisdom with all of us. And I hope everyone has a great afternoon. Stay safe and well, and we'll see you all soon. Take care. Bye.